Welcome to the Explainer. Okay, today we're going to tackle a question that every single Python developer runs into. You've got lists, you've got tuples, and you've got sets. They all hold your stuff, right? So when on earth are you supposed to use one instead of the others? Let's break it down.
And look, this is a totally fair question. If you're new to Python, you probably use lists for just about everything, and they seem to work just fine. So why even bother complicating your life with these other things? Well, the answer is the key to really leveling up your code, to making it faster, safer, and honestly, a lot clearer.
You see, the secret to telling all three of these apart and knowing exactly when to pull each one out of your toolbox, it all comes down to one single really powerful idea. And that idea is mutability. It sounds kind of fancy, but it's just a simple question. Can this thing be changed after I've created it? This one concept, this is the fundamental dividing line between all of these data structures.
Here's the best way to think about it. A mutable object is like your shopping list. It's a work in progress, right? You can add milk, you can cross off eggs. You are literally changing the list itself. But an immutable object, that's like the final printed receipt you get from the store. It is a permanent record. You can't just scribble on it and change the total. That record is set in stone.
All right, let's see this in action with a mutable list. The ID function in Python, it basically gives us an object's unique address in memory. So notice here, we create the list and then we change an element right inside of it. But look, the memory ID, it stays exactly the same. We mutated the contents, but we are still working with the very same object.
Okay, now for the complete contrast with an immutable tuple. When we reassign the letters variable here, it really looks like we're changing it. But check out that memory ID. It's completely different. See, Python didn't alter the original tuple. It couldn't. Instead, it just threw the old one away and created an entirely new tuple in a new spot. That, right there, is the heart of immutability.
So with that idea of mutability locked in our brains, let's start with the tool we all know and love, the list. This is the flexible, dependable default for pretty much everyone in the Python world. So what really makes a list a list? Well, it keeps everything in the order you put it in, and it's totally fine with holding duplicates. But its defining superpower is that it's mutable. Because it can grow and shrink with methods like append and remove, it's the absolute perfect choice for any collection of items that you know is going to have to change as your program runs.
Okay, next up, tuples. Now, if lists are all about that flexibility, tuples are the exact opposite. They are designed for one thing: creating a stable, unchangeable record of your data.
A tuple really is like a list that's been frozen in time. Yeah, it's ordered and it allows duplicates, just like a list. But the absolute key difference is that it's immutable. Its size and its contents are fixed the second you create it. You can think of it as a read-only collection.
And here's the guarantee, the contract that a tuple gives you. If you even try to change an element, Python itself will step in and just say nope with a type error. Now, this isn't a bug. This is a core feature. It's the language enforcing the rule that this data is not supposed to change, which actually protects you from accidentally modifying something you shouldn't.
So, when is this actually useful? I mean, why would you want something you can't change? Well, it's perfect for data that represents a single fixed thing, like a point with X and Y coordinates or a specific RGB color value. And because they're unchangeable, what programmers call hashable, they can do something lists can't. They can be used as keys in a dictionary, which absolutely requires its keys to never ever change.
And that brings us to our third contender, the set. And a set has a completely different job. It's not about order at all. It's all about two things: uniqueness and speed.
Sets operate on two simple but really powerful rules. First, they are totally unordered. The order you put things in doesn't matter. Second, and this is their superpower, every single item has to be unique. If you try to add a duplicate, it just gets ignored. This unique-only structure is built on something super efficient called a hash table, which makes checking if an item exists, a membership test, just blazingly fast, even if you have millions of items. And because they're based on old-school mathematical sets, you can do some really powerful and fast operations. A union, for instance, instantly combines two sets,
giving you back all the unique items from both of them combined.
Or you can use an intersection to instantly find out what two collections have in common, the elements that show up in both sets. This is way, way faster than trying to do the same thing with a bunch of loops and lists.
But honestly, the most popular trick, the one you'll see all the time, is this one. You use a set to instantly get rid of all the duplicates in a list. You just convert a list to a set, which automatically drops any duplicates, and then you convert it right back to a list. It's a super clean, really readable one-line solution to a very common problem. All right, so let's put it all together. Time for the final showdown to help you pick the right tool for the job every single time. So here it is, your ultimate cheat sheet. Use a list when you need a flexible, ordered collection that you know you're going to modify. Use a tuple when you've got a fixed, write-once record of data that should never, ever change. And grab a set when all you care about are the unique items in a collection and you need to do super fast lookups or math-like operations.
And this is the crucial point I want to leave you with. Choosing between a list, a tuple, or a set, it isn't just about performance. It's about writing clearer, more expressive code. It's about declaring your intent. When another developer, or let's be honest, you in 6 months, sees a tuple, they immediately know, this data is not meant to be changed. When they see a set, they know, okay, every item in here is unique. Your choice isn't just a box for your data, it's the first sentence in the story that your code is telling.